This is the fifth in the video series on the state space resources within the Control 101 toolbox. So because state space methods are such powerful and popular tools for the analysis and design of control systems, clearly there's a dedicated section in the Control 101 toolbox on these. And this particular video is going to focus on some resources dealing with multiple practical issues such as tracking, integral action and estimation. So a reminder that if you want to get the resources, the quickest way is through the shortcut interface, and you'll notice the circles around the particular files that this video is going to look at. So we're going to look at tracking, and then we've got two files which are much more case study oriented, looking at holistic design from the beginning to the end. So as ever, it's more effective to do a live demonstration rather than looking at the files and rather than just talking about the files. So first, this tracking file. So the tracking file deals with the fact that earlier files hadn't really given offset-free tracking. Just doing feed-forward isn't good enough on its own because feed-forward will fail. So here you'll see in the early bit it introduces this concept of feed-forward. And you do feed-forward design and everything looks fine if there's no uncertainty. But then when you introduce uncertainty, you suddenly see, hey, now we're getting offsets. So as ever, you've got the MATLAB code showing the feed-forward design and showing the simulations with and without uncertainty. So you can use these as exemplar pieces of code, change the numbers and investigate whatever scenarios you want to. You'll notice the feed forward is designed here. Okay, but the theory obviously is discussed above. And a bit of demonstration that clearly you don't get unity closed loop gain if there's any parameter uncertainty. So what do we need to do? We need to introduce some integral action. So this section talks about how you might introduce integral action into a state space framework. Again, some of the theory, explaining what's going on, and then the code that actually implements this. Now, we need to be honest that you see the code starts to get a little bit clumsy now. Can you see what we're having to do here? We're having to create these augmented matrices to cope with the integrator states. And yes, you can do it, but it is getting a bit messier. So when you go to video 6, you'll see that there may be some alternatives which have advantages. But either way, this does the code for you. It shows you how you can introduce integral action and then obviously create the responses and see does it work. We can show the example here with uncertainty, and as expected, we do indeed get no offset, but you'll see that the coding is beginning to get a bit messier. Creating the closed loop transfer functions is getting a bit messier, and so maybe doing this on pen and paper isn't the best route. Now, the final two files are more case studies, as you'll see illustrated here. So they're more beginning to end discussions. So a little bit of theory, but largely just going through, first of all, let's do one step, introduce the state feedback. Let's do some pole placement. Now let's introduce an observer. Let's introduce an integrator and so on. So you'll see these files really just are case study files going through all the content that you might have done in a first course in state space systems, and the whole content captured in a single file through some case studies. And again, you'll see the second example here. The only difference is now it focuses on a discrete system. So one case study in continuous time and one case study in discrete time. So the idea of these files is really like end of course, have I really got it? Let's work through these case studies and see, does it all make sense? Can I do all the steps? And as ever, of course, all the MATLAB code is there to support whatever computations you might need. And you can change the numbers if you want to look at different examples, but largely the code will stay the same. So in summary, this video has given a quick review of some of the resources to support a full feedback and estimation design, as you might do at the end of a course, including integral action.